Welcome, everyone, to Day 2 of Iceberg Summit. For our opening keynote, it is my pleasure to introduce Apache Iceberg committer and Project Management Committee member, Russell Spitzer.
Hi, everyone, and welcome back to Iceberg Summit. I'm really excited to be talking to you all today. And before I even get into my talk, I just want to say how excited I was to hear all of the talks yesterday and learn about all the things the community is doing. Because as I was practicing my talk here, which is about iceberg development at Apple, one of the things that I really kept coming back to is how none of the work that we've been doing at Apple as well could have been possible without this great community and all the people in it. And it's really exciting that we've all been able to get together and do stuff today. To talk a little bit about how I even got into this community, I want to go back in time a bit to when Iceberg was a much younger project. I was looking for a new job, and I was told by some folks at Apple that this Iceberg project was coming along, and they were looking for someone to work on it. And I didn't know too much about what was going on then. And what I could not believe at that point in time is the amount of success and the progress that the community has made since then. Back then, almost no one knew what Iceberg was. Iceberg was just a little niche idea that was talked about at Netflix that a lot of people were thinking could be important, but weren't really sure about. But it's gone so far, and that's really what my talk about is today, is how that journey happened with us at Apple, along with the rest of the community. So to start off, I just want to talk a little bit about what I do right now, which is I am one of the engineering managers at Apple who works on the Lakehouse environment and open source Apache Iceberg. So our team is basically responsible for making sure that Apache Iceberg is successful at Apple. And I think we've done a really good job at that. And to tell you a little about the journey we've had and the things we've done, I'm going to take you through a couple big questions. So the first is, how is Apache Iceberg being used at Apple right now? What are the kind of use cases we're working with, and where is it being used? Next, I want to talk a little bit about why way back then we made that decision to use Apache Iceberg, and then why up to this day we've continued investing in the software, investing in the community, and making sure that Apache Iceberg is successful. And then next, what are the kinds of things that we've done in that journey from that early days of the project till today that have, for us, made Apache Iceberg the right choice? What's validated our decision to go with Apache Iceberg? And in that, I'm going to go a little bit technical and talk about some of the specific things we've been working with the Apache Iceberg project and how those have been important to us at Apple. And finally, I want to talk a little bit about what is coming next, both at Apple and for the Iceberg community in general, and the things that I'm really excited about. So let's start out with that first question, which I'm sure is probably what's on most people's mind, which is, how is Apache Iceberg actually being used at Apple? So we all know that Apache Iceberg is this very portable data table format that can be used with a lot of different engines and a lot of different kinds of systems and vendor tooling. But of course, this wasn't always the case. When we first started working with Apache Iceberg, I basically would have to go out to users within Apple and ask them if they could just try this out. Could they just see how this worked for their use case? Maybe it would solve some of their problems. And now I'm happy to say that at Apple, Iceberg is ubiquitous. We've gone from that time where I had to actively solicit users to people coming to us. Our team, which is an infra team, is constantly fielding requests of people who maybe just heard about Iceberg for the first time or have seen its success in other parts of the org and are coming to us and saying, how can we make this work for our team? Now, this means that at Apple, we see Iceberg in multiple use cases. Multiple might even be too weak a word here. We're seeing Iceberg being used for just about anything you could imagine. The key benefits here, I think, are the fact that it's so portable and so usable with other systems that we find it just being able to be slotted in just about anywhere. Now, of course, one of the things about working at Apple is we also have a scale issue. We're working with tables that are not just very small, but we're working with tables that are up to the many petabytes and probably even larger in the future. And we find that Iceberg fits all of those use cases. In fact, a lot of the things I'm going to talk about later are about how we did work on the Apache Iceberg project to make sure that it can handle those larger petabyte scale tables. We want to make sure that Iceberg is not just the choice that you make because it's the one that we're supporting, but it's the one that you're choosing because it's the best for your use case. And in some cases, we found that it's actually the only tenable solution for some of the use cases that we're working with. And of course, we're also using Iceberg in all different sorts of ingestions. Apple, again, is a very large company, and we're supporting all sorts of different interoperable technologies with our Iceberg tables, which means we see Flink, we see Spark, we see Trino, we see people writing their own integrations using the Java API directly, because Iceberg is so flexible and so interchangeable between all these tools. You can have folks doing basically whatever they want as long as they're following the spec and using the APIs and have their data be accessible by other teams. So this is an extremely powerful thing. And I think one of the reasons that we see Iceberg spreading so much through the company. Now, this is all just the use case kind of side. I've been talking about all of the people that our team and other teams in my group basically support. But this is only one half of the coin of how Apple is involved with Iceberg and the Iceberg community. We're not just consuming Apache Iceberg. We have teams of dedicated engineers all working directly with the Apache Iceberg community, improving Apache Iceberg as software, and improving all of the other projects that interact with Apache Iceberg. Now, just to give a broad overview of the open source developers at Apple, we have contributors who are experienced and committers in Spark, Flink, Trino, Hive. Basically, you find an Apache project, and we probably have committers in it. This is something that a lot of people don't really think about when it comes to Apple, but Apple actually has an extremely strong open source core because we see the value in using open source software in both its portability and its ability to really deliver gains across a variety of use cases without vendor lock-in. And of course, all of our developers, when we're working with community, are trying to increase the performance and usability of Apache Iceberg for everyone. We're trying to make sure that anything we do is not just Apple specific. We want to make sure when we do an improvement, that improvement doesn't just help Apple, but it helps everyone in the community. And one of the big reasons that we do this is that we know that when we do something that helps everybody, not only does that fix propagate on through the community and continue getting improved by other users, it shows that this is a software that's worth developing and worth contributing to. We want to be sure that we're in a community where everyone feels like they have something they can add to the project and they can do something to make it better. These are all really important things for us. But that's probably getting into the question of why are we spending so much effort on this Apache Iceberg software? Obviously, Apache Iceberg is in use by a lot of people at this conference, and everyone here seems to be interested in it as a technology. But why way back then, and I believe this is a little before my time, but I think it's 2019-ish, was Apple looking into Apache Iceberg? So there's a lot of things to think about here, and I can't answer the question for all of our users who are using it, but I can talk a little bit about why we as an infra team were so interested in Apache Iceberg as a technology. And I think it breaks down into a few fundamental points, and I want to kind of walk through those and why those are so important to us now and why they were so important to us then. To start with, I think the most important thing about Apache Iceberg, when we were looking at the different options we could have picked way back then for looking for a table format, was that it's true open source software. Now, I personally have worked at a lot of companies and have often had to be in that kind of tug and pull between whether or not you're working on something that's proprietary or something that's open source. And it almost always makes it very difficult to develop good open source software. And I think almost everyone in the open source community has been in that position where they see that just one feature is behind a gate or just one special thing is on this other side of a walled garden, which means that software, while it's open source in some ways, isn't truly portable or isn't truly compatible with everyone else. And this leads to a really dangerous situation where you end up having to value the software because you're already using it and not because it has true inherent value. Now, this is really important when we're picking a table format, because for table formats, as Ryan talked about a lot yesterday, the inertia of the data, the system in which the data resides, is pretty strong, a pretty strong indicator of what engine or what vendor you're going to use to work with that data. So it was really important to us that the table format that we choose was so open that any vendor would be neutral and could work with the exact same data. So when we were looking at the different options, we wanted to make sure that we were picking a project that had this commitment to this true neutrality, so that when we chose a table format and we put it into action, our users wouldn't feel that they were stuck with a particular engine, like they had to always use Spark or they had to always use Keynote, that they would be able to go and switch between things without migrating their data. So Apache Iceberg fit the bill then, and I think this community is a great, this community conference has been a great indication that it's kept that promise, that Iceberg has still remained an extremely vendor-neutral, open-source community supported standard. Now, that's just part of the deal, right? Obviously, this is important for software maintenance and important for data portability, but we also have a lot of other concerns, one of which was ACID guarantees. Now, I know it's sometimes hard to remember those dark days of the early distributed computing, but we have to remember we used to be at a point where having any kind of consistency guarantees in your data warehousing solution was pretty much just, a hope sort of thing. For those of you who are familiar with how Hadoop operates, will know that there's multiple different commit protocols built into the HDFS file writers, all of which do different things to try to make sure that when you write data and it succeeds, it shows up all at once or none of it shows up. But that is often not actually the case. And of course, if anyone violates those guarantees and just puts files in random places, you can end up ruining the consistency of your table. We knew that when we picked a table format, it had to behave as close to relational databases as possible. We wanted to make sure we had something that had the full ACID guarantees that our users were used to working with. Now, for us, this is a strong requirement, because one of the important things about picking a table format is you need to pick something that your users will want to use. If you pick something that isn't appealing to them, only has interoperability through MapReduce or something like that, it ends up not being something they'll actually pick up. When we provided software like Apache Iceberg with ACID guarantees baked into it, then we can easily say you just keep developing your applications the way you would as if this was Postgres or something like that, and we'll take care of the rest. Now, this is something that was sorely missing from a lot of the other options at the time, and we're happy to say that it's kept with us to today, and people have been very happy about how Iceberg tables have been performing. Now, the next thing to talk about is, of course, the other side of this coin, which is the performance angle. Now, again, looking back at the early days of these sorts of table format technologies, we'll see that things like Hive and file-based tables were all intrinsically based on the fact that you needed to list all of the data files in a partition before you could plan reads of that partition. Now, when cloud technologies and cloud storages started getting introduced, suddenly what used to be a really cheap operation in the Hadoop file system, listing all of these files, became an extremely expensive operation. I'm not sure how many of you have actually calculated out the price of listing files in systems like S3, but do so sometime and think about how much that would cost when you have 20 or 30 million files in a table. You end up quickly making a simple scan of a table an expensive proposition, not just from a cost perspective, but also from a latency perspective. So we were looking for a table format that not just would perform well with small tables, but would perform really well with large tables and would perform well regardless of where we had the table stored. We wanted to make sure that if it was in HDFS or in some kind of cloud storage system, we would still have the same kind of performance characteristics. And again, Apache Iceberg came through for us there. It also, of course, has a ton of features around performance that were really appealing, including that ability to take metadata out of the file footers, putting it into a different layer, and allowing us to do pruning and scan filtering during the planning phase, rather than having to do it after we've already opened files. So a lot of cool characteristics of Apache Iceberg make it an extremely high performance system, and one that we were really excited to start working on. And finally, something that I appreciate the most is that Apache Iceberg is a relatively simple table format. Unlike a lot of other systems which might have multiple server components or multiple different things that have to be kept up at the same time, Apache Iceberg at its core is a set of metadata and a set of files on disk. And the way that you transition between one state and another is just simply switching that set of metadata from one to another. And that makes it really easy to reason about how things are happening. Why was something serializable? Why was something not? It makes it really easy for us as developers to go in and investigate the changes that other folks make. Now, for open source software, this is really crucial, because there's nothing more dangerous than having a complicated system where you have to rely on only one person who understands that particular code path to make consistency changing operations. So again, Apache Iceberg seemed to tick all of these boxes for us. It was a true open source project. It had complete ACID guarantees, and of course, the hope, I should say, it should have the ability to perform ACID transactions, and it was high performant, and again, a very simple layout to finish with, making it very easy for us all to understand and contribute to. Now, this is all a big positives for Apache Iceberg, but why didn't we choose other technologies? Well, one of the main systems we were moving off of in a lot of places was Hive. One of the reasons that we were not super excited about Hive is those consistency guarantees I was talking about before. Basically, because of those listing requirements, and because anytime a file gets put in a partition, it becomes a part of that Hive table, we had users going in all sorts of crazy directions to try to implement things which in a fully transactional ACID-based system would be really easy. So for example, people trying to do transactions, people trying to replace single files in their Hive table would find this extremely difficult. We would have people taking complete tables and building replicas of them and moving them in that way, because that was the only way they could find to correctly and semantically do this. If you had small files and you wanted to compact them, well, that's another operation that you need a transaction for, and is extremely difficult to do. And of course, we have this metastore component, which is controlling all of this metadata and is most likely keeping it in another secondary system. So it had a lot of components and made it really difficult to move things between different metastores. So again, Hive, very complex, wanted to kind of move away from that. Data warehouses. We also had a lot of data warehousing technologies in use. Now, the key problem, of course, for us is that warehouses are expensive. No one wants to be spending money on software that they don't have to. And one of the things about data warehousing is that they often, like I said before, use that lack of portability of your data as a way to, not invest as much in the technology. So we're really looking for something that would be open source, that we could use with other open source technologies, and could be relatively cheap to use. So again, data warehouses got crossed off the list. And then finally, we of course had a lot of people who were just saying, well, why don't we just do everything in file-based table? And I'm sure if we have any DBAs watching this talk right now, they are screaming out, because this is probably the worst case scenario for data management. Not only do we not have the ACID transactions that we really wanted, we also have to constantly deal with the fact that our users are going to be making copies of tables that have no registration anywhere. They're going to just take a folder and they're going to copy it somewhere else because they want to make a change. And us as DBAs will never know when that happened. And you end up with, of course, file systems propagating all over the place and data sets in all sorts of places you don't want, which is a nightmare for compliance. So with all of these things in mind, we way back then decided that we were going to focus on Iceberg as an infrastructure team. And now it's easy to see why a lot of users have seen those same reasons and have decided to adopt it for their own specific use cases. Now, that's, of course, a pretty rosy picture. We've said all the things that Iceberg can potentially do, but it wasn't always that way. So what I want to talk about next is how we went from those very early days of Apache Iceberg into the production-ready Apache Iceberg we have today that works at Apple scale. Now, we have had, of course, a lot of dedicated engineers working on this, but I want to be clear that all the work I'm about to talk about, while it has had Apple engineers involved with it, has also been a collaborative process with the community. We have a lot of things that I'm about to talk about, and I want to be sure to say that I'm not taking credit for any of this as a person or specifically as a company, but to say that these are all really collaborative efforts. Even when it's a PR that I've written myself, I know that I'm having help from other folks at other companies helping me out and contributing to the project. But that said, let's talk a little bit about the kinds of issues we had and what we did to kind of fix that. So to start with, I'm going to kind of categorize some of our problems into some big high-level themes. The first is regulatory issues. So we obviously care a lot about privacy at Apple. This is one of the core tenets of the company. And that meant that we wanted to make sure that we were properly applying all of the regulatory rules that were coming out, like GDPR and DMA. And in almost all of those cases, what you need to do is a row-level update of an existing data set. Basically, you have to go through a data set and remove a user's information if they request it. Now, unfortunately, a lot of those old systems were developed in such a way that the only way to modify a partition or something like that would be to wipe out the entire partition and replace it. That's basically the only atomic safe way of doing something like that. Iceberg presented us with this ACID transaction-based framework that we were able to use to develop row-level updates, which basically meant that we were able to start developing new methods of modifying a table at the row level without dropping entire partitions. I'll go into detail on how we did this later and the kinds of things that we're using right now, but that's just to give you a little taste of what we're about to talk about. We also found that we have a lot of use cases where people are doing streaming. We have a lot of use cases where tables are being modified very frequently. We're seeing those tables being modified, as often as every minute, which meant that we needed to make sure that Apache Iceberg could do the maintenance required to avoid any of the problems we know come with that kind of ingestion rate, basically dealing with small files, dealing with constant commits to the same place, and making sure that all works coherently. And then finally, the last topic I kind of want to go over in this talk is the scale that we've been working with. Now, again, Apple is a very large company. And for legal reasons, I wasn't allowed to put in exactly how many files we're dealing with. But they would let me say that we're basically trying to figure out how to make sure that Apache Iceberg works at almost any scale of files. We want to make sure that there's no situation in which a table is made that Apache Iceberg can't handle it. So we've done a lot of work in that area as well to make sure that Apache Iceberg continues to scale. So let's dive into these one at a time and kind of talk about the technical improvements that developers at Apple have been working on to make sure that that's possible. So starting with that regulatory sort of problem, we wanted to figure out how we can enable large-scale row-level operations. So the first thing that probably everyone here knows about is copy on write. So copy on write was the first implementation of row-level operations in Apache Iceberg. Now, to set up the scenario here, imagine that you have a, 10 petabyte table. And within this 10 petabyte table, you have a few thousand users whose data now needs to be expired. Now, those 10,000 users exist within maybe 2 files in a partition that has thousands of files. You want to be able to change just those 2 files without changing the entire partition. So copy on write was developed as a way to achieve that kind of modification. So copy on write goes in and says, I will locate just those files that need modifications, take them, erase them, and write new versions of just those two files and transactionally replace the previous files with those new versions. So it ends up being a really great way, if your deletes or updates are centered in a few specific files, of updating just those files. Now, I'm sure thinking about that and thinking about all the work that went into it, that sounds really complicated. And of course it was. And we had a lot of prior art in the space to borrow from when we were implementing it. But this was just step one, because we quickly realized that for a lot of our use cases, copy on write was just not going to cut it. We had a lot of use cases where the data was not going to be clustered based on file. We were going to have data updates that were spread along an entire data set, covering all sorts of different partitions and all sorts of files within them, extremely sparse. So that led to the development of a second mode. Again, this is not a completely novel technique, but is one that we were implementing in Apache Iceberg to make sure we would be successful, and that's merge on read. So merge on read is the second type of row-level operations that Apple engineers have been focused on to try to make sure that we can handle these kind of large-scale row-level operations. So think back to our scenario again. I have 10 petabytes of user information, and I only want to delete, 1 gigabyte of it. But that 1 gigabyte is spread uniformly along my data set. Now, in this case, if I replace every data file that has a modified record, I'm going to end up wasting a lot of time rewriting data that hasn't changed. So merge on read does this really exciting thing, which is it just writes an accessory file next to the data file that says these rows inside of that data file have been deleted. Now, there's a lot of cool technical things that happen behind the scenes within the Apache Iceberg spec to make this all consistent and work properly. But basically, having that technology let us quickly enable these kinds of giant delete use cases that are spread out instead of just concentrated in one place. Of course, that wasn't enough for us in our biggest use cases. We still had issues because we just had so much data, so many files. And to that end, we've worked on even more things. And I'm not naming engineers by name right now particularly, but all of the Apple engineers are really great. And I'm sure if you go and look up these PRs, you can see exactly who worked on all of these things. But quickly moved on to distributed planning and delete file read improvements. So we went back into the Apache Iceberg codebase, looked at all the places where we were bottlenecking, and figured out, how can we improve this? Because we have those large delete use cases, and we want to make sure that they keep scaling up to even larger data sizes. Because we know that the current data sizes we're working with are only the biggest data sizes we're working with today. They're not going to be the biggest ones we're working with in 6 months. So we continue to make improvements in all of this technology. But of course, even this was not enough. These copy on write and merge on read operations still had some core bottlenecks that we wanted to improve. And those were basically stored around centered around the fact that to do these modifications, I need to locate which records to modify first. Now, the way you locate records that you're going to modify in a data set is typically done with a join. Now, the way that we wanted to fix this is a way that, so joins are really expensive in distributed systems, let me put it that way. And because they're really expensive, we wanted to make sure that we had a way of eliminating them if possible. And one of the things we found is that in a lot of our update use cases, we were actually joining data sets to locate these records to delete based on partition key, which meant that there's a technique that's used in a lot of other systems, bucketed joins, which we thought could be used within Iceberg. But as all of you know, Iceberg has a lot of different partitioning functions. And we realized that that technology could probably be applied in general to any kind of join where the storage format can define a partitioning transform. So this led to the development of storage partition joins. Now, this is one of those awesome cases where we had engineers at Apple working both in Apache Iceberg and in Apache Spark to make the required changes to make this awesome technology now possible. So for all of you who have looked in Apache Spark in the last few releases and have seen storage partition joins get added, those have been added because Apple engineers saw an issue, specifically here in row-level operations, and thought, how can we not only fix this problem for us, but fix this problem for everyone in the Apache Iceberg community? and Apache Spark community. And this is just one of the things that I'm really excited about in open source technology. We saw a problem, and not only did we figure out how we can make it better, we figured out how we can make it better for everybody. And, true to form, after we released this, we saw other users from other parts of the Apache Spark community jumping on board and helping out and increasing its performance, fixing it in situations where it didn't work correctly. And again, the open source community worked exactly like we wanted it to. Unlike proprietary enhancements to engines and things like that, which won't necessarily help everybody, we introduced one great change, and it was just followed up with more and more excellent additions that made the system even better. Now, these are all cool things that basically have enabled new use cases at Apple. All of these technologies combined let us do these updates, which previously just were not possible. We had a lot of users who came to us with problems of this scale who just told us, we had been writing custom solutions to deal with this. We had to write our own merge engines. We had to write our own specialty software, and they didn't want to maintain it anymore, or they thought it was inefficient. And we came in with this setup, and suddenly, not only do they have a community-supported technology that does this, which frees them up to work on other things, but it lets them take on use cases that previously might have been completely impossible. So again, very exciting work here, but that's just one of the main themes I wanted to talk on. Let's talk next about streaming and ingestion issues, which basically to me boiled down to mostly maintenance. A lot of you who are beginning your Iceberg journey have probably talked to me on Slack at some point about maintenance procedures, because this is something very dear to my heart. When you have jobs that are putting data into your Iceberg table, a lot of you will know that the metadata that you make is immutable, which means that every single time you make new metadata, you're basically adding more and more metadata. So you need to have systems that collapse this metadata down into a more compact form, as well as systems that look at your data files and compact them into more compact forms. Now, this is another place where Apple engineers looked at the initial Iceberg project, looked at the initial systems we had, and said, we really need to scale this up so it works at Apple. Because we had tables that were so large that some of the original implementations for some of these things took several hours to run. And I know even now we have seeing tons of places where we want to increase the performance and maintenance procedures. But we basically went in then and made sure that we would have distributed versions of all of the maintenance operations to make sure that we would be able to scale them up to our largest tables. To this end, we've, of course, contributed patches that have allowed users to rewrite data files, rewrite metadata files, and rewrite delete files. Because we're, again, realizing how critical this kind of technology or this kind of algorithm is to a functioning Apache Iceberg table, we wanted to make sure that all of this lived in the open source community so everyone can take advantage of it, everyone can look for bugs, and everyone can look for ways to improve it. And I'm, again, really excited to say this is another story of where when we introduced something to open source, other contributors from the community jumped in and made all sorts of improvements. Things that we didn't even think about when we were developing the system at our scale came up for other folks at their scales. So it's, again, a really great win-win story for the community. And while these are pretty simple to talk about, the next thing I want to talk about is a more complicated topic, but really more exciting, and another one of those great collaboration stories, which is write distribution modes. A lot of folks know that when you're writing data into an Iceberg table, the old behavior, if you think about the way old days in Spark, would be to basically write a new file for every Iceberg partition that lived within a Spark task that was writing data. It's a little complicated to say, but basically you can think about it as the number of files that your write produces is the number of partitions in your Iceberg table times the number of tasks in your Spark job. Now, for those of you who work at a company with with tables that are very, very large, you can imagine that that multiplication becomes extremely large, and the files that you produce might end up being very, very, very small. So we were constantly running up against this. We had all of these great maintenance procedures that could rewrite and basically after the fact clean things up, but we wanted to make sure that we could clean them up at write time. We wanted to make sure that when we were doing writes, we were doing them efficiently the first time, rather than writing it out, reading it back, and then rewriting it again a second time in a more compact form. So to this end, again, engineers at Apple working on both the Apache Spark project and the Apache Iceberg project worked to develop write distribution modes. So this was a way that we, again, made it so that Spark could communicate with any data source, not just Apache Iceberg, and ask that data source, how should I arrange this data before I give it to you to write? Whereas before, it was just basically, however the user gives me the data, I'm going to write it. Now, Spark could ask the data source, what is the ideal distribution of data before we start the writing procedure? And to that, we've added various modes to Apache Iceberg. And of course, I believe it was just in Apache Iceberg 1.2 that we switched to the hash distribution mode as the default Spark write mode. And I can tell you, since that's been introduced, the amount of people coming to me and complaining about small file problems has dropped dramatically. And this is another thing that, again, when we added it to the community, it became available for every single person to use. This isn't just an Iceberg specific thing or even a Spark specific thing. It's a technology that within Spark can integrate with any other different kind of data source. So other data sources like Cassandra or something like that could take advantage of the same information to optimize their own write behaviors. So again, these are all really exciting things that alleviated a lot of the problems we had with the initial Iceberg releases and things that we've been focused on. But I wanted to talk lastly about the scale issues and the things we've done around there. Oh, sorry, I forgot one last thing. I just added this in because for those of you who are on the mailing list, some of our engineers have just put up some proposals to address the streaming maintenance issues at the source. So some folks who are using Flink as their ingestion engine, please check out the proposals that are being made, which basically say we're going to integrate these maintenance procedures directly into a Flink pipeline so that you don't actually have to use separate systems. And a Flink pipeline can not just ingest, but can also do its own maintenance. So please check that out. Sorry, I forgot I had just added that in. Very excited about that proposal going out. Now, talking about scale, I wanted to talk about some of our biggest performance enhancements and the things that we've been working on there to make sure that our largest tables perform well. The first has been our work on the vectorized readers. Like I said before, we've been very focused on that merge on read technology. So one of the key things we've been investing in is making sure that the vectorized read technology works with our merge on read style reads. We also, of course, have been dedicated to making sure that the vectorized read path works. And I hope you check out the talk later today on some other engineers from Apple who are working on Comet, which is a complete rewrite of the vectorization path, not just in Iceberg, but allowing vectorization to be used directly within Spark as columnar execution. So a lot of cool things happening in that space. I don't want to go too much into the details there because I'm running a little low on time, but let's continue talking about some other things we've been working on. The next thing I want to talk about is a shout out again to not just our Spark team, but also our Trino team. We've had engineers who have been working hard to make sure that when you do queries on Iceberg tables, you can take advantage not just of pushing down predicates to filter data, but you can also take advantage of pushing down aggregates to push down aggregates into Iceberg metadata. Now, if you aren't aware of this, one of the things you're now able to do in both Trino and Spark is do a query on aggregates that exist within Iceberg metadata and have those queries answered directly from the metadata layer. Now, this is a huge benefit. As much as I'm excited about columnar execution and vectorized reader, these are the kind of orders of magnitude performance enhancements that really come with having these enhanced metadata layers that are associated with Apache Iceberg. Now, on top of this, we, of course, have also been working on the push down of V2 predicates in Spark. If you don't know what that means, it basically is basically means that now when you write queries in Spark, you can actually use Iceberg transforms directly. and then have those transforms pushed all the way back down into Iceberg. This is something that, again, wasn't possible before. And not only did we make it possible in Spark to push down these transforms, we also put the technology into Spark to allow this to happen for any data source. So again, we're making those kind of contributions that don't just help Apache Iceberg, don't just help Apache Iceberg, don't just help Apache Spark, and don't just help Apple, but help the entire community and anyone who wants to interact with any of these technologies. So again, the kind of contributions I'm really excited about. The next thing I wanted to talk about is our big scale problem of migrations. So as I've talked about, Apache Iceberg is everywhere right now at Apple. And one of the things that means is that people come to me with extremely large tables that are already existing in Hive, and they want to move those into Iceberg. Now, this is really hard because those are very, very large tables usually, and copying all of that data from one place to another is usually very expensive. So we invested, of course, in procedures, if you might have seen them, the migrate and snapshot procedures, to make sure that if you have a table that already exists in another format, you have a way of moving them into Iceberg directly and without copying any of the data. And of course, this has led a lot of other improvements in the Apache Iceberg project as well, as we've seen various other technologies added to the Apache Iceberg repository and ways of taking data out of those technologies and moving them into Apache Iceberg, again, without actually copying any of the data files underneath. So that's a lot of things that we've been working on and we've worked on in the past. Next, I want to talk about what we're going to do next. So obviously, this has been a lot of work. We've been working on a lot of different things. And you might think that this is about the time we should just rest on our laurels, accept the fact that Apache Iceberg is a really great technology and we've basically done everything we needed to do to make it successful. But we're not going to stop here. We're really excited about Apache Iceberg as a technology, and we're dedicated to contributing to it in the future and making sure that it's not just successful today, which I can tell you it is very successful today, but making sure that it is still successful in the next years to come. So to do that, we have a lot of specific projects that we're really interested in, and I want to talk about here, not just to talk about the things that we're going to do, but to ask actively for contributions and collaborations from other people in the community. Because like I said, this talk, while it's called Iceberg Development in Apple, is really about Iceberg development with Apple. We want to work with the Apache Iceberg community on all of these things to make the Apache Iceberg project better. So let's talk about our near and long-term goals here. So basically, one of the key things we're still really interested in improving in Apache Iceberg is performance. We know that the data scale that we're facing today is probably still going to only be, will probably be a joke compared to the data scale that we're working at in 5 years. We need to be sure that the systems that we're building continue to scale with the data that is growing in our systems. So to that end, we have a couple things that we really want to help push forward. One is indexing. We're really interested in the various ways that secondary indexing can perform within Apache Iceberg. We want to make sure that these integrations, again, can be done in a way that's vendor neutral, that's swappable, that's able to work with other systems so that we're able to develop an index that Trino, Spark, Flink, that all systems can use independently. And of course, those are just the engines that are popular right now. Who knows what will come out in the next couple of years that we might all be using. We're also extremely interested in views. Now, at the moment, the view spec is merged, and materialized views is what I'm really excited for in the near future. So if you haven't had a chance, check out on the mailing list. I think there's another thread going on right now talking about materialized views. But to tell you why we're really excited about this, let me talk again about those order of magnitude improvements I mentioned with the aggregate pushdown. The thing about materialized views that I think is really exciting is they take multi-petabyte data sets and they basically turn them into megabyte data sets. A materialized view is a way of taking a data set and cubing it up or shaping it into a form that a query engine can deal with way more rapidly. And those are the order of magnitude performance improvements that we're really interested in. This is also a feature that's currently currently available in a lot of other systems, but not quite yet available in Apache Iceberg. And Apache Iceberg is, again, the right place to do this, because Apache Iceberg is this table format that, again, is extremely portable between all these different engines. If we do this right in Apache Iceberg, it means that all of our users using all of the different engines and all the different programming languages that they like will be able to take advantage of them. So we're very excited about the work going on there. Statistics work is going on even as we speak. There are engineers on my team currently actually pushing pull requests for the analyze table command for Spark right now. I urge everyone to go check that out. But this is, again, another one of those places where if we just add a little bit more information, a little bit more compatibility to some of the engines, we can all take advantage of information that is basically owned by the table, but can be utilized by everyone. And last but not least, in my performance category, I'm really excited about Geo. This is another proposal that's recently started appearing on the mailing list. And geometric types basically offer a brand new set of use cases to us. We have a lot of users who are, again, in Apache Iceberg, are able to work with geometric data, but they have to do their own kind of UDFs. They have to do their own structs. If we can get a geometric type baked into Apache Iceberg itself, we're going to be set up in a way in the future to handle these kind of cases way more easily. And of course, with those geometric types comes special types of partitioning that work better with geometric types. So really excited about that sort of stuff. And finally, I hope all of you got to check out Gideon's talk yesterday. We're really dedicated to the encryption project. For us, encryption is a necessity for the table format going forward. Because if there's one thing we don't trust, it's anything. We don't like trusting our storage. We don't like trusting our metadata. We want to make sure that we have as many redundant systems as we can to ensure the security of our data. So one of those key things for us is making sure that Apache Iceberg natively supports encryption. Again, because if Apache Iceberg as a format doesn't support encryption, that means all of the different clients and engines won't be able to support it in a compatible way. We want to make sure that encryption is baked into the format itself so that regardless of what engine you're using, regardless of what programming language you're using, and regardless of what vendor you feel like talking with, they will be able to handle your Apache Iceberg encrypted tables. So again, these are all things that we're working on right now. Please check out the proposals that are available in open source and the PRs that we have up, because we're really excited to work on all these things with you, which really brings me to my final message, which is that Apache Iceberg has been a great community project, and we really want to keep it that way, and we want to actively invest in that. And for that, I'm, again, inviting everyone, please come talk to us in the Apache Iceberg Slack, send us emails, send proposals on the mailing list. The Apache Iceberg project becomes stronger because we're all working together. And I'm really excited, again, that at this first Apache Iceberg Summit, I see that spirit so strong in everybody here. Well, hopefully next time we'll be able to meet in person. And if anyone here is looking at this list of all of these things that I've decided, or I've said that we are going to be working on and wants to work with us directly, please let me know, because we are always available for new folks to come work with us here at Apple as well on the Apache Iceberg stack. With that, I basically would like to wrap up. I'd like to let you all know that I hope you have a great day today at Apache Iceberg Summit, and know that the next talks, I believe, are starting at 8:15. So I hope you all have a great day and a great time at Summit, and I'll see you all later.